Entity Framework Core on the query side of CQRS, or something else? Well, this was the topic for a video posted by Milan Jovanovic, and I had a member of my channel ask me for my thoughts on this topic in the video. So I started watching it, and then I caught myself talking out loud. So then I thought, well, why don't I just record me watching the video and providing my thoughts? So here we go. Thanks to EventStore for sponsoring this video. EventStoreDB is a new category of operational database built for event sourcing, CQRS, and event-driven microservices. For more on EventStoreDB, check out the link in the description. I also sent a tweet to Milan asking him if I could do this type of video, which he said go ahead, but just note that I'm not advocating this approach. It was more of a how you could do this if you wanted to. And I'll have a link in the description to a counterbalance video that he posted.
How do you implement the query side of the clean architecture? Are you depending directly on EF Core or SQL, or are you making your queries completely persistence ignorant? In this video, we're going to explore what options we have and what are the pros and cons of each approach.
Okay, so it was mentioned, clean architecture was mentioned in there, but the query side of that, I think really, maybe that was just a mix up there, or we're talking about clean architecture and CQRS in the query side, and then talking about EF Core or something else. But also what was mentioned in there was persistence ignorance. So I think that's where the clean architecture part gets in, of kind of abstracting some of this data access.
First, take a look at the get order query handler, which is depending on the iApplication.db context interface. If we take a look at this interface, you're going to see that it's just a wrapper around the EF Core database context, which is implemented in the persistence project. It's exposing the database sets of the entities that we are using in our domain, and the benefit of this approach is that you can directly use link queries in your handlers, and it's pretty easy to write your queries.
All right, let's stop right there. I actually want to back up a couple slides here and show this, is that I often see this where there's some interface that's being created, and the purpose of exposing it, injecting that, is then you're kind of abstracting Entity Framework Core and making maybe it easier to test. I understand that you are kind of hiding some implementation details of Entity Framework, but at the same time you're not, because you're still exposing the DB set. Again, I say if this is about testing, you can test the EF Core. That's not like really, to me, a concern. So I really see little value in having this iApplication.db context.
Queries in your handlers, and it's pretty easy to write your queries. The disadvantage is that you are depending directly on EF Core, and you have different abstractions present in the application layer. For example, here we are using the iApplication.db context for queries, but in the create order command handler, we are using the approach with repositories and the unit of work to implement the flow for creating an order. It's easy to see why this would be confusing, because you have multiple paradigms mixed in the same project.
So I'm going to stop there as well, because if that's confusing, I think it's just a different understanding of why you're using CQRS. That's the purpose. So if you have your query side deciding, hey, I need to get closer to the data, I'm not going to extract as much. Maybe I'm using EF Core, Dapper as the example I think that was mentioned. You're doing it because it's a very specialized query. That's the point. On the command side, you're likely, if you have some type of rich domain model, you may be using aggregates and returning an aggregate root from a repository. Again, aggregates are about being a consistency boundary. They're different concerns. You don't need to return an aggregate root on the query side because you're likely overfetching data. Again, if you're not making state changes, you don't need the concerns of a consistency boundary. That's why you're doing it on the command side. They're just different purposes. So is it confusing that on queries you may access data one way using different libraries, different tooling, than on the command side? No, I mean, that's kind of the whole purpose.
Raw SQL queries with something like Dapper or even EF Core suffers from the same problem as this approach, where we are using EF Core directly. So how can we implement the query side so that it is persistence ignorant like our command side? We're going to start by...
Okay, so persistence ignorance is coming into this here.
By creating an order service, or you can even name it order read service so that it's more obvious what it's doing. So let's define this service, or rather just the interface for this service, in the root folder of the orders feature folder. So let's say this is the I order service. Now I'm going to make this into an interface, and what we're going to do is we're going to move this query here into that service. The method is supposed to return a task of order response, and we're going to call it get by ID async. And we're going to accept the order ID argument, which is also used in the original query. Now our get order query handler is going to depend on this service, so I order service, and we're going to inject it from the constructor.
Slight pet peeve, I'm stopping here. Calling everything a service kills me.
Now the order response is not going to be coming from this query. It's going to come from order service get by ID async, and we're just going to pass a new order ID. So the end result is that our query handler becomes extremely thin. And
so it became extremely thin, and what value does it serve at this point? So we have get by ID async that was doing that actual call. We just move that call, that entity framework call, somewhere else in a separate class. Now we're depending on this. We just added indirection. So I'm still lost on the value here. The thing is that again, I said this earlier, this is specialized query. That's the point of a query, is to be specialized. So this get by ID async really is kind of generic in the naming, because it's not really, it's returning the order response. This thing is, the order service is being called, and it's returning exactly the response that this handler needs to return. So it's like if we were returning a more generic order type of object and then transforming that, I still wouldn't be behind that either. But you could see that that's actually when people start getting into the, well, I got to map this object to this object to this object from layer to layer to layer. That's why we get into this place, is because we have this indirection.
There's pretty much nothing inside. If we also get rid of the dependency on the iApplication.db context, this is what we are left with. Now, it would probably be a good idea to also introduce a null check here. And for this to make sense, I'm going to change the definition of this method to return a nullable order response, because it could be the chance that we get a null response from the database. And the appropriate thing to do would be to throw some sort of specific exception in this case. So let's say we have an order not found exception, and we're going to pass it the order ID value.
I'm going to jump over this part. I remember it. I think this exception and throwing in this case and returning null is a whole different design discussion than kind of this video was about. So it's kind of a side tangent. So
let's see, make this
okay.
into
So we
order read service.
Sorry, I skipped a little too far. We renamed the order service to the iOrder read service.
Or it can even be query service. So naming is pretty important, and I think this expresses the intent much better than the previous name. For the implementation of this, let's head over to the persistence project, and let's create a new folder which is going to hold our services, and let's add the order read service implementation. So order read service, it's going to be an internal and sealed class, and we're going to make it implement the iOrder read service. We're going to inject the DB context directly instead of depending on the abstraction, and I'm going to just copy the implementation that we previously had in the application project, and we're going to try to fix the things that are broken. So I'm going to start by making this asynchronous. We need to update this to use the order ID that we got as the argument. And we no longer have the cancellation token dependency because I decided to leave it out. Fix.
Okay, so basically what happened here is the query, as we expect, got moved here. We're not depending on the interface anymore. We're just depending on the DB context directly. And I'm kind of following along here, is that's now because we're actually in the persistence project. So we really don't need that interface. We actually have the DB context here, hence the part about clean architecture. So I'm following, but I still don't see the value.
The indentation here, and we should just be returning order response. Now for this to be nullable, I'm actually going to use the overload that returns single or default. And the slight problem with this approach is I'm calling single, which is going to throw an exception if there are no records found, because it is expecting exactly one record from the database. So let's use first or default async, and we're going to let our application layer throw the more specific order not found exception. So this is how you can move your query into the persistence project and make your query handler completely persistence ignorant. The downside is your queries become just a thin wrapper around whatever is the query service, in this case the iOrderRead service. We shouldn't forget to register the iOrderRead service with dependency injection. So let's go ahead and do that in the persistence project. We're going to add the iPersistence. Let's try to move another query into the iOrderRead service. Let's take a look at the getOrderSummary query handler. This one is really straightforward. It's just querying the order summaries and returning the one matching the ID.
So this is really interesting here, because what's happening is instead of having, again, a specialized query, in this example, it's actually just returning the actual underlying data model from the DB context. So this order summary is what is in the DB set. That's actually what's being used in our context, and that's what actually is what's being returned here. So there is no transformation. We're just basically creating a path directly to our database and exposing ultimately kind of our schema, our implementation details of our data.
Already simple enough as it is. If we try
which I don't recommend
to move this into the iOrderRead service, we're going to have a method.
So as the example, the order response, that was completely different. It was kind of creating with link a select a projection to return something specialized, but this one is not. We're just actually returning the underlying data directly.
That is returning an order summary instance, and we're going to call it, let's say, get summary by ID async. Now the ID in this example is a GUID, and if I go back to my getOrderSummary query handler, we can replace this with an iOrderRead service, and we're going to add iOrderRead service here. We're going to rename this from context to OrderRead service, and this is going to become OrderRead service get summary by ID async, and we pass it the order ID. And in the implementation, we're going to move our query right here. So this is going to be return await and the query that we had earlier, fetching the order summary by the ID.
So an interesting note about this as well is, I mean, you can get my feeling already, but removing the cancellation token kind of to me is like the indicator of, well, what's really happening here? We have the cancellation token inbound from the actual HTTP request, and then we're just offing it for some reason when you really wouldn't want to be, because you want to be actually passing that to that database call, but we're removing it from this API. Again, if you had to pass that cancellation token deeper within layers, deeper indirection here, it's kind of the indicator of like, oh, this feels uncomfortable, and it should be the indicator.
This is how our order read service looks like, and our getOrderSummary query handler is again just a wrapper around the order service. This feels pretty pointless because your query handlers become just simple wrappers around some sort of service that is fetching the data. This is because there is pretty much no logic present in the queries themselves, other than throwing exceptions in some situations. If we introduce throwing some sort of exception when the order summary is null, then this starts making a little bit more sense. The actual value is that we are using mediator here, and we have access to the behavior pipelines, which we can use to introduce some cross-cutting concerns. One of those could be introducing caching to specific queries. With this approach, introducing caching becomes pretty straightforward. Now I'm going to try.
I appreciate that it was acknowledged that this seems kind of useless, because it is, unless you're adding more things to either the handler, about checking the response, or doing something with like, because this is using mediator and having some type of pipeline for your request, where you're going to be doing other things. Let's continue.
To refactor this slightly, we're going to make separate abstractions, and this is going to be similar to the vertical slice architecture and the concept of vertical slices. For example, we could do something like this. Introduce an interface in the get order summary query folder. Let's say I get order summary. This is the interface name, and it's going to return the same order summary response as the previous method that we have in the iOrderRead service. And let's just give it a method called execute async, and we're going to give it the ID argument required to fetch the order summary. Now, instead of using an iOrderRead service,
so where this is getting broken down now, instead we're going to have an interface that has execute rather than having the iOrderRead service that had multiple different methods that need to be implemented for each different use case, which is, again, a specialized query. It's a use case. Now we're going to go an interface per. I don't know who said it first, but I keep repeating it, which is if you have a function, if you have a class with one method, or if you have an interface with one method, you have a function. So what we're about to do right now is take an iRequest handler that essentially is a function that has one method to handle. And then we're also going to have an interface that's going to have one method, this execute async.
we are using something like this. The implementation of this would again live in the persistence project. So let's say in the services folder, we have a get order summary class. It's going to be internal and sealed, and it's going to implement the iGetOrderSummary interface. So let's copy the implementation from the OrderRead service. So this is going to be our implementation, and we have to make it asynchronous, and we are just missing the application DB context dependency. So let's inject this from the constructor. So this is our getOrderSummary class, and now our getOrderSummary query handler is going to depend on this instead of the OrderRead service, and it's going to have just one method. So getOrderSummary. So now we are not depending on the OrderRead service. We are using a small service that is scoped to our query exactly to implement the required logic. Let me try.
So I stop here again. So the idea being, okay, we moved it now into its own separate class. The value of there is you had this, likely you would end up with the original iOrderRead service, its implementation as well, would likely end up very large because, again, you're creating specific specialized use cases. That's the point. But again, I go back to, this is what this thing's going to look like. If you needed to add something else to it, some type of cross-cutting concern, I often find that you're likely not going to be doing it for everything. It's going to be individual use case of maybe this particular handler, which you may do actually here, a part of the handle, some other different way. Caching always gets brought up. It got brought up here. I think caching is a really poor example generally to use because caching is not easy at all. And it's not just like, oh, we'll just throw a cache on something. There's a lot of implications with it. However, I get cross-cutting concerns are a thing. I don't think caching is one of them. But the idea here is that we have this thin query handler that's calling some other handler. And if we're adding indirection right now, and there's actually I'm lost on the purpose of the actual value here. I believe the value or what's being presented or the ideas of how this could work is because we want to get persistence out of these handlers. That's kind of the motif here, is we want to move persistence, that persistence project. So that's why we're kind of moving everything there. But in doing so, you're just adding indirection for what purpose? So that you don't have persistence directly within this handler. It's exactly going to be a one-to-one-to-one almost.
I'd like to highlight a few benefits of this approach. One is that you can make these small services very specific to your query. You can decide which implementation you want to use. So in this example, we are going to use the application DB context or EF core directly. In another example, we may decide that it's more performant to use SQL. And in another example, we could decide that the most performant approach would be to use some sort of key value store like Redis. This is practical when you have a lot of queries in your application and you are facing the problem of the order read service, in this example, having too many methods and become...
So I'm fully on board with what he's saying, is that you're tailoring your use case to how you actually want to do it, whether it's for performance reasons. There's a magnitude of reasons why you may do it. I'm just still can't get behind of why adding the indirection.
Becoming quite a big class with a lot of code inside, which is difficult to maintain, and it's difficult to know which specific method you want to call in a specific use case. Another symptom of this is that you're going to end up with methods that are called in a single place in your code base.
Sure.
So it makes more sense to use a specific approach like creating some sort of abstraction, in this case the iGetOrderSummary interface. The downside of this approach with vertically sliced abstractions is that you're going to end up with a lot of small classes. For every query, you would have a specific service and a lot of classes to maintain. If you want to know how to easily introduce caching using the decorator pattern, you can watch this video.
All right, so that's the end of it. What are my total thoughts here? So here's the overall gist that I got from the video and what my thoughts are. So I think the point of it, really clean architecture plays an important role of what was trying to be accomplished, because using Mediator, having a query and a query handler, the idea was, okay, well then how, if I'm applying clean architecture, do I remove access from that data directly? So at first it was saying, okay, well, we're gonna have that iApplicationDB context, and because I'm assuming, because you're still slightly exposing EF core and persistence, we want to remove that persistence completely. We don't want to be using that interface. We want to remove something separately so that we can expose some other interface that's going to really encapsulate that data access and everything about it. The two ways that were mentioned were just kind of creating that read service, which it was also mentioned was just going to get polluted by all these specialized queries. So instead was then creating a separate service interface and implementation, again, per query type, which then you would end up in a mapping of a 1-to-1-to-1. I see little value in this. I see little value in trying to abstract data access of a specialized query, because that's what the query is trying to do generally. I say this because if you're concerned about abstracting it because you don't want to depend on it and you don't want to be coupled to it, the key word there is coupling. How coupled in terms of usages are you? If you're coupled to, say, some particular DB context and you have like hundreds of usages because you have how many different DB sets in it, that's actually the problem. Not that you have, if you have, for example, a dozen usages of a DB context that you have and you wanted to change what your persistence is, you could go ahead and change it. It's not like you have 1,000 usages. Having all that coupling is the problem. Trying to abstract these usages and adding all this indirection, I really don't know the value of it. To me, it's more focusing on coupling, how you're using these libraries and frameworks, how you're coupled to them, rather than to abstract them, but still have 1,000 usages. That really doesn't solve the problem. So overall for me, it's just adding indirection. There's little value. I think it, on the query side, on the command side, that's a different story. It was using repositories, fetching on an aggregate, sure. On the query side, again, it's specialized. It's whether it be for performance reasons, overfetching data, there's a lot of reasons, but again, it's a specialized use case. That's the point of the query. Making it more difficult, if you add more layers, add more mappings, you're kind of defeating the purpose there. If you enjoyed this style of video, let me know in the comments. I've done similar types of things before, but they're usually around blogs. I've done one recently on Amazon Prime Video and serverless, McDonald's, event-driven architecture, Wix microservices, things like that, and I enjoy doing them. If you want to get access to a private Discord server where you can talk with other developers about these topics or provide a suggestion like this, because that's where it came from, you can join my channel and get access to that private Discord server. Links in the description on how to join. If you enjoyed this video, please give it a thumbs up. If you have any other thoughts or questions, make sure to leave a comment, and please subscribe for more videos on software architecture and design. Thanks.